So this is the video on calculating percentage composition from chemical formula. The chemical formula can be molecular or it can be formula unit depending on if the compound is ionic or covalent. So we have this equation: percent composition equals mass of element in a compound and the total mass of total molar mass of a compound times 100 because you're finding the percentage. Okay guys, so here they can ask you the question like calculate the mass percent, or the question could be just direct calculate the percent composition of sucrose. So here the calculate the mass percent of carbon, hydrogen and oxygen, but it could have been calculate the percent composition just of carbon or hydrogen or both or all, hydrogen and oxygen. So let's work on this. This one we have to figure out the molar mass first. What you need to know for finding percentage composition is, first thing you need to know the chemical formula of the compound that you're working with, and then you need to know how to use periodic table to determine the molar mass. So one and two things are must. You have to have your periodic table handy. So let's work on figuring the molar mass first. We have sucrose. So sucrose is actually a table sugar and the formula is 612H22O11. So you have 12 moles of carbon, 22 moles of hydrogen and 11 moles of oxygen in 1 mole of sucrose. So carbon 12, that's where I'm getting this 12 from. 22 is for hydrogen, 22, all right. 11 is 11 for oxygen. These are the molar masses for 1 mole of each of these elements from periodic table. I have round off all of them to 100th place. Then you multiply each of them and what you get here is the mass of that element, total mass of that element in a particular compound, whichever compound, and in this case it is sucrose. We are talking about sucrose. So let's figure out, our job is to figure out what is the percentage of carbon, what's the percentage of hydrogen, what's the percentage of oxygen present in 1 mole of sucrose. So let's start with the carbon. We write mass of an element. So please make sure don't write these masses. These are the masses for 1 mole. We have to write the mass for each of these elements in a compound, right? So for this one, this is what we are going to write. Carbon, 144.12 grams of carbon. At the bottom, you write the total mass, and this is our total mass. Molar mass, and molar mass, the unit is grams per mole. 342.34 grams of sucrose. I'm just going to write sucrose. You write the molecular formula. Just doing that to save the time. Equals 42.098%. So what you did, you have used your calculator. 144.12 divided by 342.34 grams of C12H22O11 and then times 100. So what you're doing is just dividing these numbers, multiplying by 100. Don't forget to multiply by 100. Sometimes the students forget. That doesn't give you the percentage otherwise. So make sure to multiply by 100. Okay. Let's find out for the hydrogen, what percent of hydrogen? 22.22 grams of hydrogen. And where am I getting these numbers from? I'm getting this from here for hydrogen, 22.22 grams. Total, 342.34 grams of sucrose. And then you do times 100. This number divided by this number times 100 is going to give you 6.491%. Now let's see hydrogen. How much is the hydrogen? Sorry, oxygen. Oxygen. So we did for carbon, hydrogen, and now we are doing for oxygen. So oxygen is 176.00 grams of oxygen divided by total mass, grams of sucrose, right, times 100. Use the calculator. This number divided by this number times 100. You are going to get 51.410%. Now, how do we verify if our result is correct? and we are doing our problem fine. So since it is a percentage, we want to check that it adds up the all these percentages, this percent and percent, they all should add up to near 100%, if not exactly. So any number, any percent in between, let's say 99.6 and 100.4% is acceptable. So when you add this 42.098 plus 6.491 plus 51.410, you are going to get 99.9%, which is equivalent to 100%. All right, guys, don't forget to put the percent sign. Just remember, don't put these numbers here. You have to put these numbers. You are writing the mass, total mass of that element in the compound, not just the element, not just the 1 mole. Okay, let's do another problem. Okay, percent composition, calculate the percent composition of ammonium sulfite. So we need to know the formula. Formula for ammonium sulfite is this one here. Okay, NH4 whole twice, SO3. So how many moles of each element, each atom is there? Let's see. Each one, we have hydrogen, so 2 times 4, and then nitrogen 2 times 1. 2 times 1, 2 times 4. Sulfur is 1, oxygen is 3. So look at my nitrogen, 2, because 2 times 1 is 2. Hydrogen is 8, because 2 times 4 is 8. My sulfur is 1, because here just 1 sulfur. Oxygen is 3, because this is subscript 3. So look at the subscript, and the subscript which is outside parentheses, it goes with all the elements which are inside the parentheses. You add all these, you're getting this total mass of the compound. This gives you the mass of a compound. Okay, now our job is again to figure out what percent of each element is there when making 1 mole of ammonium sulfite. So let's start with nitrogen. Nitrogen here, we are not going to write 14.01, we have to write 28.02. Okay, since we are writing the mass of element in a compound, and this is the total mass from here. And please do not forget to do times 100. Then let's do the percent of hydrogen. 8.08 grams of hydrogen over the total mass, 116.16 grams of ammonium sulfite. Sulfite, not sulfate, sulfite. And then times 100. Do the same thing for sulfur. Percent of sulfur here, 32.06 grams of sulfur over total 116.16 grams of ammonium sulfite times 100. Do not forget to multiply by 100. Okay, the last one is oxygen, 48.00. Remember, these are the numbers we are using, not these, not these, these. Grams ammonium sulfite, grams of oxygen times 100. Now use your calculator to solve them. Numerator over denominator times 100. When you do that, this is what you're going to get here. The percent, 6.96%, and here 27.60%, and 41.32%. Use your calculator, multiply, add them. Add this number, this number, and this number. All these percentages, all 4 percentages, when you're going to add them, you're going to get 100%. Once again, anything close to 100% is fine. Well, you can't have like 102. That is too far. Like, that's a significant difference. But anywhere between 99.6 and 100.4 is fine. Okay, now let's work on this you guys try this problem. I want you to try on your own. Here you go. The problem is calculate the percentage composition of acetamide. So you're finding how much is the percentage of carbon, hydrogen, nitrogen, and oxygen in 1 mole of acetamide. Double check everything, guys. And one more thing you have to think of is significant figures. So for instance, when you got here after dividing these and multiplying by 100, this is what you had. However, I changed it into 40.66. I had rounded off here at this place. The reason is because I'm using the significant figures rule as well. 1, 2, 3, 4, and here you have 1, 2, 3, 4. So you look at the problem, and your answer should have the same number of sig figs as the number with the least number of sig figs. Okay, then you add all percentages. When you did that, you should get this one. I did it, and then 100%. And if that's what you're getting, that means you are doing a great job. Now I want you to try this independently without any help at all. If you have trouble, go back and revisit, and please read these. This is everything I said in the video. Thank you. Hope it was helpful.